tool in our day-to-day design activities. So one thing, very candidly, this is going to be like a photo album of sorts of things I have collected over the years. Some of these would be models that I've also folded. So let's see what's there. So starting with my favorite word, origami. What does that mean? So let me show you a few images of things that you might remember from your childhood. Like the paper boats that we used to fold on rainy days, or paper planes. Remember those segments we used to make in our notebooks while we used to partition the notebooks into two subjects? And of course, the fortune teller. So all of these are in some way origami. So origami basically comes from two words, oru, which means folding, and kami, which means paper. So this is the Japanese art of paper folding. And here we see an old woodcut art from Japan where ladies are shown folding origami birds. So just a moment. Is this visible? Yeah. So to start with, the crane. The crane is the oldest documented origami model that exists. So these are some cranes I had folded. If we can make cranes, of course, we can make a lot of other origami models, other animals also, birds and all of that, figures in origami. These are all single sheet models. From there, we also come to multi-sheet models, which are basically modules connected together to create something which is a bigger whole. So these are all conventional ways of creating origami. But in the modern times, there's something called modern origami as well. So these are more sculptural, more towards the artistic value of it, relooking at how paper could be folded in a different way to not really create just figurative models, but also something which is abstract, something which talks about something beyond what is apparent. So as much as I have explored inside architecture, we mostly deal with these modern techniques in origami. Throughout the presentation, we'll be dealing with these three questions: what, why, and how. So what can one do with origami in architecture? You can start exploring form, like these two projects from China. They take up the form from origami and then they build on that. Temporary structures and pavilions where you don't require the structure to stay for very long. It's a good idea to use something in origami which is lightweight and easily, quickly installable. So something like this helps. Shading devices. Well, this is a project that I had explored in my first year, and this tower is in Dubai. It's called Abu Dhabi Towers. It's called the Al Bahar Towers. I'm so sorry. It's called the Al Bahar Towers. And as you can see, that is the facade of the tower here. Just a moment. Yeah. So this is the facade of the tower. And they use a very basic idea of having triangles. These are the triangles. Sorry. So these are the triangles. And what they do is each triangle has just the medians drawn on them. Like you can see inside this triangle, just the median lines dropped perpendicular from each vertex. And when they can fold, it folds basically like an umbrella. So you would know Dubai has a lot of sun. So you want to shade that sun inside this office building. So each of these triangles can individually open and close to basically shade or not shade a certain segment. And it really works just like an umbrella. Then dynamic facades. Dynamic facades in terms of actually moving facades, like the one I showed previously in the shading device example, as well as this one. And facades that have something more than just a flat, plain facade. So details like these happen with origami, with the use of the idea of origami. Well, next thing is the interior design that can be done with origami. One can see here is just the wall being detailed out in that way. It's not really a folded piece of paper or anything. It's an idea of origami that is being implied on this wall. This structure here basically takes the wall as well as the ceiling to create this one undulating surface created out of origami. Again, we are using polygons there. This is a staircase that is inspired by folds, how a folded staircase would look like. And this here is basically using a module and decorating the inside of a space, something like an installation. Then coming down to the most smallest unit, if we may say, a furniture. There's a wide range of furniture that is being made in origami, like tables, bookshelves, chairs, lamps, and lamp itself is a huge topic inside origami, where there are n number of ideas that you can use for lamps. And then the last one is installation design or set design, where you need, let's say, a background for a dance performance or something like that. People have been trying to use these folded surfaces to generate something that gives an aura more than what a flat surface would have given. Well, why is origami used in architecture? We saw what all places it is being used, but why? So the first thing is aesthetics. You might recognize the lotus temple. Well, all of these shells actually are folded in a way, right? That little edge on each of the petal creates that shape of the flower. So that is also folded. And this is one of my favorite installations by one of my favorite origami artists that I look up to. So this is called the Song of the Earth and the Sky. It's a temporary installation that was put up in Sundar Nursery. Again, because of origami, it's got that sculptural look. Then the next important thing that architects use for origami for is the structural stability. One can see here, like we talk of frame, like we talked, I'm so sorry, like we talk of the shell structures and frame-based folded plate structures. So folded plate structures are nothing but folds, right? So origami. So one can see here all the members that are there in an origami model that you would make out of paper. They can be the structural members for making it at architectural scale with real architectural construction materials. So making these models helps us understand where exactly the structural stability is required, where all the members would come. Like, for example, in a tent, we put the members at the exact positions because we know that by folding, this is exactly where the members would come. Then about deployability. Let me explain this with an example. Let's imagine we're going out on a picnic. So we would pack up our picnic mat and go and open it right there in the garden, right? So a mat compacts itself into something which is like a bag-like size, and it can open and a lot of people can sit on it. So what it does is there's a concept called deployability, which means that we are able to transform the size and shape of a certain thing so that it is easier in transportation, and like a pop-up model, it will open up and it will quickly set up. Where this is used in architecture is night shelters. Let's say during the day that lawn or that open grounds is used for some other activity, and at night we put up these shelters and people can use it at night and then again pack it up and like use that ground in the morning. Also during emergency requirements where we quickly need to put up some shelter, deployability is very important factor there. The other thing that can be seen in civil engineering, not so much in architecture, would be bridges, right? So bridges can be quickly unfolded, carried in a truck, and then unfolded on site to use to cross a certain river, and then again folded back and put in the truck and carried away. Then these two things, it is less material intensive, like all folded plate structures are, and it is handy and quick when we are talking of origami models, quick models for discussions during architectural discussion, any kind of discussion during a jury, during a crit session. You want to quickly make a model, make changes, so it's very handy. Then how can origami be used in architecture? We've understood what all it can do. We've also understood why all are we using origami, but how exactly? I've divided into 4 parts. The first would be direct inspiration for form. This would be something like at a concept stage where you like a certain sculpture made in origami, and now you're trying to imagine that as a building. So obviously, if this is a sculptural building, the core could be the central thing that is going straight, vertically straight, and then the floor plate can keep shifting accordingly. Of course, this would require architectural resolution after this, and it would be constructed in real architectural materials, maybe some conventional material, but we are just taking the form from a sculpture that exists. So this is a model that I had designed and folded. So I've tried to put it at an architectural scale to show you what can happen. Then the next thing is origami has very deep rooted mathematical calculations underlying all the forms. So this is something called a hydrangea. It's a fractal geometry. One can see that there's a square and then it's rotated again to fit inside it by 45 degrees and then rotated again to fit inside it. So one can then understand what are the proportions. If this is one square and the dimension is L, what is the dimension of this, so that it fits inside, like perfectly fits inside that. So we get these proportions quite well. And the other thing we can do, once we get these proportions, are let's try and relook at the same shape as an architectural concept. What if this innermost square was an inner courtyard or an angan with 4 rooms flowing out of this courtyard, and 4 service areas, let's say toilets and kitchens and storerooms flowing out of this. And then at the edges, we have something like balconies or green spaces. Again, this is at conceptual stage, but one can, of course, figure out how to resolve it, but you get the proportions. That's more important here. Lastly, the folding technique itself, which means in the construction itself, not just in design, but in the final construction, we are using a sheet-like material and we are folding that sheet to create something which is the final model, right? So, so here you can see that actual construction drawings can be made for these folded plates. Details can be figured out. Of course, the way we fold paper, it's almost thin and the thickness is negligible. But when we are folding something which is thicker, of course, the joints have to be detailed out, and they still work on the same principle of mountains and valleys that are there in a paper model. Like this one is a paper model, but they use almost similar principles as is seen in a folded frame structure. Finally, we can also use an origami model that exists. Like this angel was used, and about 10,000 pieces of these were made during the pandemic, and they were hung as a ceiling for a cathedral. So what one sees is that instead of creating something new, you're using an existing design and just filling the space with that, like we saw in that installation as well. Well, at this point, let's go a little hands-on and let me try and show you what we can do apart from this. Yeah. Let me try and show you hands-on what all can happen. Like, of course, paper being my favorite material to work on. So if this is a sheet of paper, this is something you guys might have done somewhere or the other in structures class, is that when it's very thin, this pen kept on top of it, it's going to sag. And more the weight I put here, more the sagging would happen. So if I try to do this, it's going to fall off. So, but if I had a lot of sheets here, let's say a full ream of sheets, then this pen and a lot of other things and even a book could have rested on top of it. So what is it with this paper that we can do using origami that will help this sheet sustain the weight of this pen? Let's try and fold it. This is an activity I think my structures faculty had taught me. And then I realized that this also is origami. So if you see this, I've made a fold, and I'll make 2 more folds. basically creating a structure for that. So 1 and 2. I've divided that paper into 4 parts, and you see this here. So basically I've made 2 mountains and 1 valley, and now the pen can rest much more easily here, like that, right? What we've done is we've changed the way the load transfer is happening. So now the load is transferring through these triangular members, right? So if I were to fold this further and make more creases here, while I'm doing it, if any of you have sheets of paper with you right now, you can also start folding and exploring this for yourself. I think it's much more intuitive when you start folding it on your own, and like that. So I'm increasing the number of folds we have, increasing the number of divisions. At one point, what would happen is, like, we have a lot of beams. So between 2 beams, you're trying to suspend something. We could also try and suspend that on a waffle slab or something like that, which is smaller beams, but a lot of them spaced closer to each other. So I've divided this sheet now in 8s, right? Right? So these are smaller segments. And if I further divide it into 16ths, another thing you can notice while I'm doing this is I have all this as a mathematical division, which is 2, 2 to the power of 1, 2 to the power of 2, 3, 4. So these are all powers of 2. So now at 16, we are at 2 to the power of 4. So I'll just divide it. And like you can see, it's quick and it's not very, what do I say? Not a lot of complex materials that are being used here. So as our day-to-day design activities, you just want to, ideate a certain space. Origami really helps. So now I have creased it in 16ths. I've made the folds for 16ths. I'll just collapse it. Again, we're doing something which is a very basic fold, like a fan fold, if you remember from childhood. Yeah. So I'll just crease it once on one side and again on the other side. So I have folded this paper in 16ths. Yeah, so this paper is now folded in 16ths. Now you can notice that I can even rest my phone on top of it without it really collapsing. The triangles are still maintained, if you can see, right? So what we have done is the phone could have rested on a ream of sheets. So we have made it also less material intensive. With a single sheet of paper, we are able to balance the phone. And also it can collapse into something which is, see, this dimension is much less than the dimension like this. So if this was a bridge which is spanning across, let's say 30 meters, now it can be collapsed into something which is like around a meter or even less than a meter, right? Now let us look at something which is, I'll just make one fold here, like that. I've made a diagonal fold to try and show you one of the models that we've seen. These are all working on corrugations. So now what has happened is, if you can see, there is a second dimension that has come to this sheet. It's not just in this direction that the structural members are there. This direction also has structural members. If I again put another member here, see, I'm doing something very basic. I'm just folding it in like this and incorporating the folds inside. So if I just fold it this way. And since we're using our hands to do this, it's much more, I think it, to me, it churns the creative juices much more. So see, this is something that would work as a portal frame. We directly already have something like a walkway or a portal frame, or perhaps it's an elevated road also. It could be anything. So I'll show you something here. See, when I'm collapsing it, the shape that we see is more or less an upside down, let's say a U kind of a thing, or a trough, an upside down trough kind of a thing. And when I start opening it like that, at some point of completely opening it, it will become flat. So the curvature that we have here, the radius of curvature is the least when I have collapsed this entire thing. So the radius of curvature here is the least. And when I start opening it, it starts increasing. So with that single sheet of paper, with that single form that we have, we are able to change the curvature while we extend and collapse this sheet, which means that for, let's say, a building that has an undulating surface, so we need to clad something on that. So now we have, with the same dimensions, the dimensions of any of these structures don't change. So one can get glass cut or any cladding material cut in this shape, let's say in these trapezoidal shapes, and then just align them as per a certain angle. So when the angle changes, you see, when the angle between two members changes, that is when it gets flat or not flat and the curve changes. So in reality, the curve is not changing, it is just the angle that is changing. So it's an easier way of prefabricating and installing on site for any of the, you know, various kinds of undulating surfaces on our walls or on the external facade of a building. Now I could also show you this model, which has now a lot of folds. So it's done in the same way. It's got those divisions, and then it's got those diagonal folds all through it, right? So now what is it? It could be just a form of art, but does it have some architectural significance? Does it also talk of, in terms of design, does it also talk of a building that's got one part that's protruding outwards towards the road and one that has sunk in, and in that way what it creates something that we probably could have done with conventional architecture also, but this helps us see what are the proportions that look nice. And like I mentioned, because it's a quicker way of doing things, you can make multiple of these, like how you would do it on a software. You would keep iterating. You can also do it in a model and do this, and then you want to then look at this as a shading device. Let's say it's hung to a lintel and the whole thing is on the top, and when you want to pull it down through a pneumatic system, through a pulley system, you can pull it and it covers that shading, that window. The reason I wanted to do this hands-on was also so that you realize that it's not as far-fetched as it looks when we see images on Google. Most of the images that you saw in the presentation were of buildings that have already been created. But since this is more for people like us who've just graduated, who have not really put a building out there, probably understanding that yes, it's possible is very important. Then I'll show you something else with this is, I'll start using I'll take another model. Yeah. So this one, again, the same thing is happening. There are corrugations, but the angles and all are different. Now, these angles are dependent on how we want to make that sculpture. Like this, if this was the side facade of a building, let's say, you know, you want a terrace garden kind of a thing at this mid level, and then you want the wall to go up like that. Or you want, instead of that, you want something like this. So you see there are differences in the edge sections that we can design. And now I'll just use this and try to rotate it and complete the circle like that. with the center being the center axis for this, what we see here is that we've got a completely new shape. Earlier it was more of a rectangle, and now we've got something which is more cylindrical. And of course, this could have happened with a single sheet of paper also. You could have taken this and done that, right? But this is much more interesting to look at, to actually do that, and not just a cylinder, but having that indent there, doing something there. And with the same thing, with the same model that I made a cylinder out of, and maybe this is an office tower building, but maybe this is also a part of a dome, a bigger dome. Like if I stretch it like that, it's also part of a bigger dome that can go around this like that and create a dome which has this shape. So it really depends what we are using this origami for and how we tend to design it. Of course, like I mentioned, here we are only talking about how to design models. How to really construct them in architectural scale would be something which requires a lot more of a conversation, which is about resolving them structurally, detailing the hinges out. Here we are only talking about how to design the models. So I'll show you another one. This here is, you see, more or less flat on the edge also. Like this had a curvature. This model had a curvature, right? And this is more or less flat. So what happens when I open it? It's still flat. So it's not really adding anything in the third dimension. But what it's doing is, when I open it, the size increases in both X and Y dimensions. So this is what deployability means, or flat foldability. I can fold it, carry it, and then open it wherever required. And this probably then can be a pattern you use for a facade or for an interior also. And the moment you change the angles here, the model really changes, the design changes. So angles, dimensions, these are things that we play with and we change patterns. So with that, I'll get back to screen sharing and showing you a little more. Yeah. So after that, I wanted to show you some of my applications of origami in architecture school. Right. So this was a quick activity. So where we just had to use bits of paper, which were, each paper had just a single fold. So something as basic as this. So the moment this happens, there's a very bold language to this paper. It's no longer flat like that. There's a bold language to this paper. So this was something that I was exploring, maybe a public building, and using these little birds as a scale was very interesting. And like I mentioned, it's very quick to make changes in origami, especially at the designing stage. So here I've just changed the color, nothing else, to get a different vibe. Like this and this are absolutely the same organization of paper, just the color changes and the photograph angle is also changing. So what that gives us is a different perspective of that same model. Now, this is a false ceiling installation that I had done in college, the last installation, and just before the pandemic started. And we folded sheets of paper, stuck them together, painted them. And this is what happened. This is the lift lobby of our college. And it was for one night that we'd put this up. So paper was a affordable solution for that. And so it quickly covers the whole ceiling. And there was light from in between the real ceiling and this false ceiling. Then this model I had shown previously also, it's a lamp. It's an abstraction of a lamp. It was put up during Diwali in our hostel. And the idea was to take the essence of what a diya or a lamp does. The idea is to light up the space, right, with diyas. So here we designed a huge diya basically, which looked like, yes, light was there, it contained light, and paper was used to have that diffused effect. And because of these folds, it was able to stand on its own. It's just hung with a few ropes, but it does not collapse or anything because of the structural stability that paper gives it. or origami folds give it. Then these were perceived as dew drops or os ki boonde in another festival where we had put these up, I think in Eid. And each of these now is an individual model. In each of these individually basically has no paper cutting or no gluing, so it's technically origami, and there's a light bulb inside each of these, and then you repeat these to give that effect. Then this might be a bit of a nostalgia for people joining from SPA here. This is basically a tree that used to be there, a cut tree that used to be there in our volleyball court, and how you can perceive art through it. How, it's weighing down with the burden. Of course, paper is not so heavy, but the idea of it being chained and being weighed down. So you can create art, not just architecture, but art out of origami. Now, this is a model I had done for my school design in third year. This is done using software, but how do you make that thing flow in that way? Yes, of course, sketching is one way to do it, but also taking a very long sheet of, this thing, which can twist and turn. So you add lot of sheets and make this very long, and then take it and turn it in any way. So that is when I got these gaps, these openings, where all those openings actually come in paper. So those are the exact places I put them in this model also. In that same model, when we had started detailing the little parts out, so this is how I had visualized the facade to be something which is basically this kind of a pattern, which is called a herringbone pattern. And only the structure from this model was taken and used as the diagrid structure there. Now it can be a lighting solution. Like I mentioned, lamps are a big thing in origami because of the way they play with light and shadow. So this was one of my photography assignments where I tried to use light and origami. Again, light and origami, how folded structures deal with light. Then this was a roof I had helped a senior with. So you see, again, you can deal with the shapes. So the senior had just gave me a sketch of how he wanted the roof to be, and then I had then detailed it out in origami, how actually folds would come up so that the roof, the final shape comes the way he wants it to be. Then this is something like a pavilion. So once you get into the habit of folding, or maybe it's just me, I just keep folding throughout, right? So this ended up looking like a pavilion, so I clicked it in this way. So you see, in some far future, if I really want to build a pavilion, maybe I'll just take this image, take this model, and see what are the structural lines and what scale I want it to be and what material I want it, and maybe I can just create it architecturally. And finally, this is a vault. We do these workshops very frequently in SPA, and this is an outcome of that, where we looked at how structurally a model can stand. So it's a freestanding structure. It's just an archway like that and extruded in the other direction. So it's a vault, and there's light inside it. So we see that light and shadow, and all these lines you see, like I've been mentioning, are structural lines. And finally, I'd like to end with this image, which is basically a lot of origami models from one of our workshops. And I'd like to say that the possibilities are infinite. Once you just get folding and once you start exploring, there's just n number of things that you can do. And I hope you guys continue folding. And well, thank you.
Thank you so much, Santrupthy. It was a very elaborate and informative presentation. So participants can now ask questions. If you have questions, you can either unmute yourself and ask, or if you want to put it in the group, Telegram group, you can do that as well, and I can ask them for you. In the meantime, I would request if Kamal sir, if you had a few comments or your views, if you could share your views about the presentation with us.
I think it's a excellent presentation, and the hands-on thing added another dimension. So Santrupthy is a very talented person. So we look forward to working with her also in future. So excellent work in my opinion.
Thank you, sir. Thank you.
Thank you. So yeah, if participants have any questions, then please feel free to ask them. In the meantime, I think I would, let's say, start with the questions. I do have two questions for you, Santrupti. So the first one is, for example, you just like just before your when you were giving your hands-on, you mentioned one of the patterns, right? Like the name of the pattern. So my question to you is there like a library of set patterns that in origami that probably are like usable or with instructions on how to reach those folds? Because as far as I know, like origami does have, like you also mentioned, that it has a very mathematical connotation behind it, right? There's like a certain number of folds and methods to go reach certain shapes. So is there like a library of these sort of folds available?
Well, not a library exactly, but this is like a language. So like the English language has alphabets, and then you join alphabets to create words, and then order to create those sentences. So what we have in origami are basically mountain and valley folds. I'm talking about these kind of corrugations only. So we have mountains and valley folds, and when we change, the moment we change this dimension, if you see here, the only thing that is happening is about the dimension and the proportions. So this was a, let's say this was a trapezium here, and the moment I change the dimensions, it also becomes a triangle here. So you can change the angles and the lengths to create those patterns. There are two basic things happening. One is called this, it's called a herringbone tessellation. What happens here is there is a vertical division, and there are these diagonal zigzag lines. So the moment we change the angle between these zigzag lines, the moment we change the frequency of these lines, patterns emerge. And the other thing we have is this, are triangular grids. So if you see the difference between these two, if I try to zoom in, there are parallelograms that are formed as surfaces. Each of these plane surfaces are basically parallelograms here, right? And here what we get are triangles. So either you can play with triangles or parallelograms, and then you can keep changing the dimensions. So of course you can create your own designs also.
Okay, thank you. And then I do have a second question, but before that, I would want to know if like so any of the participants want to like ask anything or have anything that they want to say about the presentation.
Speak.
Yes, Adi, please go ahead.
Yeah, the thing about our origami architecture is that like it's very easy to like I am into origami and like inculcating origami in
Adi, if
architecture.
you could, I'm sorry to interrupt, but if you could just first introduce yourself and then go ahead with the question.
Pardon?
If you could just like give a small introduction of yourself and then go ahead with the question.
I can't hear you properly. Hello?
Hello?
Yeah, hello?
Yeah, so I'm saying if you could just give a small introduction about yourself and then proceed with the question.
Oh, yeah. My name is Adi. I am from SPA Delhi, first year. So the reason like why I was very keen on joining this meet is because I was like our first class workshop had a origami assignment, and like it had this herringbone structure and all that. So I was like very hooked to that. So that's why I knew I had to join here. So the thing I wanted to ask is that basically it's very easy to fold and mold structures in paper, and like say that it's going to work out in architecture, but how is it really possible when you like work with such big loads of structures, like the materials and all? It's not really that easily collapsible. So how do we really inculcate origami in architecture, like the materials I'm talking about?
Right. So there are two things that can happen. One, like I mentioned, is that you directly take the form. So you create a cast and you put something like a slurry material, concrete into it, and The appearance is that of an origami structure. The shape is like that, but it's not really folded. And the other way is to actually fold that structure. So, have you seen how an umbrella works? It's got structural
Yes.
members and it's got a membrane on top of it. And when you open it, basically the structure expands in a certain way,
Yes.
and the membrane on top of it, because of that structure expanding, it takes that curvature shape. So in a similar way, if you have the structure in place, by using, let's say, any frame based structure, you make those triangles, right? And you
Mhm.
detail out the hinges. So each of these, um, like let's say each of these, let's look at this. Let's look at these triangles, right? So if I
Mhm.
can make frames of these triangles, make two triangles, and then detail out a hinge in between them, right,
Okay.
at the right position. This has to be further studied upon a lot, because I was working on a roof structure where it took a lot of time to actually figure out where the hinge to be put. The hinge is put now, so this, now there are two triangles that can move. Now since there's another triangle here, you start seeing where that hinge would go, so that this moves. And you keep doing that for hinges and structures. So this is where you have a frame and you put a membrane on top of it, like a sheeting material.
Mhm.
Like how you would see a sloping roof kind of a thing. So you make that entire grid and then you put a membrane on top of it. And the other way to do it would be to actually pick up a sheet like material. I've seen it in installations, not very sure about architecture, but let's say we use polypropylene, which is a plastic material. You can directly make
Mhm.
half cuts on it, and it's thick, it's thicker than paper, and it's waterproof also, and it can last quite a while. So you make those folds, and you can just actually install it on site at real scale. So yeah,
Okay.
these are 3-4 methods that you can use. Another thing would be also, right, like I mentioned, that the dimension also changes, like the overall output dimension changes, not each of these
Yeah.
frames. Then there is also a factor of hinges, the factor of pivotal joints that is required, not just hinges but pivots, so that angles also change. One is this angle changing, the other is
Mhm.
the angle between two lines also changing, not just two planes but two lines also, two edges also changing. So that is where a pivotal joint is required. So in such a case, you detail out each of these joints.
Yes. Thank you.
Okay,
Welcome.
thank you, Adi, for the question. Yeah. So if anybody else, okay. So I see Alia wanting to ask a question. Alia, you can go ahead and ask now. Alia.
Hello, can you hear me?
Yes. Yes.
Yes. Hi, everybody. Hi, Santrupthy. I really enjoyed your presentation. It was really, I'm into paper folding, actually, origami, the original
Alia, sorry
Japanese.
to interrupt again. Again, so if the
Oh, I have to
participants could just
introduce
give a
myself. Yeah,
small
sorry.
introduction of themselves and then
Yeah, yeah,
we'll
yeah.
go ahead with the question. Thank you.
Yeah, yeah. So, my name is Alia, and I'm a pass out student from Jamia Millia. And currently, I'm working, but since I'm really into paper folding and origami, the Japanese version or that we all know. So when I saw about this live to join it, connecting it back to the architectural significance that it has, I looked at some really interesting structures that which I have not seen before as well. And one thing that you mentioned during your presentation was that it could be used for makeshift homes. For example, if you need if you need to create safety center or habitat center or something like that in for a short period of time for some kind of after a natural disaster or something. So actually I was more into understanding what kind of material that will go along with it, and how how large spans you can create with it for if you just say that half football need to be covered with it. How do you for creating kind of shelters, and how efficient that is in placing it, removing it, and how durable that is when it comes, because these are always placed in exterior environment and are generally never taken care of. So, and are low cost, not to forget.
Right.
So,
Yeah.
I mean, material point of view, if you could throw some light on that.
Sure. Thank you. So, in terms of material, any kind of I've seen these houses, these temporary houses being made of ship containers, let's say, that is plastic basically. So plastic, I think, first material that comes to mind. Also, in countries that are colder countries, we use metal sheets, which are aluminum sheets, and all of those. Also, because each of these triangles or parallelograms are not going to change shape, so they can be also insulated fiber boards or anything that fit into these frames, and the frame itself is a steel structure. So it could be any of these sustainable materials that we can talk of with insulation. It could also be wood, for that matter. And right, so any sustainable material that you want at basically anything that you would have generally used without the origami, also you can still use that material, but the way you use it changes, right? So like if you want glass, of course not for this specific case, but if you were using glass, you would have just cut that glass in a certain shape and put it in there in a certain way. So I think the material does not change because of origami. Also, about your large span, the question about large span, there are various softwares that can analyze your model before you actually take it on site. So you can do a 3D model of that, and then it'll give you the stress that this model can take, whether you need to change the dimensions of trusses and all that. So it works similar to how you would have analyzed a truss or any other folded plate structure on a software.
Yeah, so my only concern and question lied around that are we able to use, since if I want to make it a cost-effective method as well for the specific case that I discussed for safety shelters or things like that. So in that case, I mean, obviously cost will be a major driving thing for me. So in that case, will I be able to use any renewable sheets, or I mean something that has already been used before if I get my hands on something like that? So I mean, according to your theory, it should be usable, right? It's just the way of folding it or the way you design it.
Yes.
Yeah, I think that answers my question. Thank you.
Welcome. Also, another thing is that these are all triangles, right? So you're just joining them together, and it's like Lego blocks now. So if you want a bigger shelter, you add a few more rows of these triangles. Or if you want to split it into two parts, just split the structure there, and they're two parts. So these are also reusable. Yes.
Yeah.
Okay. Thank you, Alia, for the question. Yeah. So if anybody else wants to ask, the next person who wants to ask can go ahead.
Hello.
You can just unmute yourself and ask. Hello.
Hello, Tushar, this is Humair.
Yes, Humair.
Hello, Santrupthy. This is Humair. I am a practicing architect in Meerut, and my question, kind of revolves around what Alia had asked, and it's in a similar dimension. I wanted to point out that origami, or when we talk about parametric architecture in a similar fashion, it looks and feels very fancy and novel, like contrary to the conventional architectural techniques that we are practicing currently. So it now calling it fancy and novel makes it costly, makes it expensive than the conventional architecture. Then do you have any experience or any comment on can we make it less cost effective and comparatively eco-friendlier than it is right now? Because you mentioned that you are using in terms of origami, we are kind of projecting outwards towards plastic or materials which are uh, less in weight, and they are collapsible, and they are either flexible, or they are more flexible into designing such shapes. So do you have any comments on that?
I think the first thing about material intensivity, I had also mentioned this, that like folded plate structures, origami structures are going to take up less material because they can sustain their own structure, right? So And I have an experience where it was cost effective for us to create an origami false ceiling, because it takes up that much of space. It takes up a good 1.5 feet for that false ceiling. So that depth, if I would have gone for some other material, I would have to actually fill that depth up. But here, like you see, I'm actually filling about an inch here, but it's not really filling it up pura pura. So it's basically there and not there in a way. Some people like to call it a fractional dimension. So yes, material is being used less. That's the first point. And the other thing about what sustainable materials can be used, I have seen structures that use bamboo mats as the infill. So infill could be anything, right? So again, all of these that we're talking about are all foldable structures, where we're saying that the final product is going to have some folding mechanism there. So this infill could be bamboo, it could be, I've also seen cloth being used, canvas being used. So these are ways I think that we can look at sustainable materials. Does that
Okay,
answer my
thank you,
question?
Mayor.
Thank you.
Thank you, Mayor, for the question. I can take one last question. So if
Yeah, can I ask?
yes, Abhinav, please go ahead.
Yeah, first of all, thanks for the wonderful presentation. I've been real on and off in watching it because I was in some work. But I mean, looking at architecture from the eye of origami is like a new thing for me. So first of all, thanks for bringing it to us. I'm sure Tushar and I, who keep on doing a lot of architecture competitions, will definitely use this at some point in time. And thank you for doing it. But I mean, on like the practicality side of it, I mean, it's good for competition and all these fancy things that again Umair also mentioned. Uh, while you say that it requires lesser material, don't you think? So I do a lot of industrial architecture where we are making these fancy facades which look like origami and all that stuff, but they require a lot more workmanship and all the, I mean, turns out to be more expensive even if you're using lesser material. What's your take on that? Because I personally feel the moment you have so many of these turns and curves and edges coming out, it means a lot of kind of expenditure going into it. So what's your take on that?
Well, there would definitely be some give and take. So, uh, if you do want to have an origami structure, you will also have to have skilled labor right there. You'll have to have someone who constantly supervises how to do that. And technology has advanced to the stage where we've got softwares that can actually help you with that entire detailing, or something like an unroll surface kind of a command, where you will get those dimensions and all. Yes, it might end up being costlier, but there are also examples which say that it's not as costly. Like I saw this example of the Hemkund Gurudwara at in Himachal Pradesh, where they've just used something that would be similar to an umbrella structure, just ups and downs. So there they're using it for snow because they need it. So when you require it, when you're trying to use it, then of course somewhere or the other the cost would come in. And personally, my idea with introducing origami to architecture is to just push this artwork into architecture, and to show architects that there is a different way of designing as well. The logistics, like you speak, there would be things to consider. I agree, but then yes, that is what it is. Like even sir mentioned during my introduction that I like to bring people together via origami. So most of the installations I have done are all hand folded in that way, that we don't involve any kind of laser cutting or anything. So of course these are not actual architecture scale actual buildings, but by involving more people, I'm able to get them to talk to each other and also fold and learn a new skill. So personally, to me, it's not, the cost has not been a problem till now. But yes, what you're saying is also right. Like there would be a cost factor.
Okay, thank you,
But I
Abhinav,
mean,
for the
so I'll
question.
tell you what
Uh,
I mean, I'll add some little bit more because I mean, I assume that I've done some more architecture than you from what I listened to you. So when you're working with the hills, which Tushar and I kind of do quite often, when you're working in the hills, it's actually good to do origami structures because it's lightweight and you can kind of mold them wherever. Even if it's a little more expensive, logistics costs become lesser because of the lighter weight. So it's much better to do that. I just kind of challenge you with my question to kind of understand what you feel about it. But that's my take on that.
Right. Thank you.
Okay, thank you, Abhinav, for the question. I think with this, I would like to bring the webinar to a close. So before closing, I would like to inform everyone about the Every Friday webinar series being organized by the Peria School of Architecture. The webinars are a platform for young professionals to express their ideas and is aimed at students and young architects. Further, we will also be running short-term courses in summer schools, and like the information for them will be shortly released to the general masses. With this, I would like to end today's webinar. I thank Santrupthy for this wonderful presentation and for introducing us to this new dimension of design. I thank everyone present here, and please have a good day. Thank you.
Thank you.